Hello, and in this video I will be talking about unique pointers. How do we use unique pointers in real applications? It's gonna be a couple of videos long. I already prepared it. It's gonna be 2 or 3 videos total because I'm gonna go in detail. And in the last video we will be creating a very tiny, like an example project where we have a game and there's a lobby. We enter to the lobby and then we will enter to the game, and we can see how would we use unique pointer in that kind of situation. I'm not going to create the game, but just the lobby and how we enter the game, and just a very small code. But let's start cracking this and let's start understanding what is a unique pointer. I'm kind of assuming that the knowledge of a raw pointer is understood in these videos, but I will shortly talk about the raw pointers. So the raw pointers are pointers from 70s and 80s where we need to, it goes like this. So we have, for example, integer a, and we say new int. So we are creating an integer dynamically here, and then we need to delete it later on. We need to say delete a, like this. And if we forget to do delete here, we allocated memory and there's a memory leak because we forgot to delete that. Okay, if we create like a b, like normally like this, we don't need to obviously delete that. This will be automatically deleted, this memory, when the scope ends. But if we allocate to the heap, so-called heap, this is allocating memory to the heap. So the heap memory is not automatically destroyed. So the user needs to always destroy like this. And the problem is that we might forget to do this. And sometimes it's actually difficult to do this. I have experience of this. So sometimes it's a little bit difficult to delete it in the right place. So unique pointer comes and helps here, because when we have a unique pointer, unique something like this, unique pointer, and then we create p, we don't need to call delete for this guy. Okay, no need to do anything. It will automatically delete the memory if we allocate memory new int somehow, something like this. It will automatically delete this memory from the heap when the scope ends. And let me now very quickly draw about these pointers. So just a quick one. So let's create this again, this integer a equals new int. Okay, so we are creating integer dynamically. It goes to the heap. So this is the heap memory. It has an address, and then it has the, the value. So let's say the address is 51. This is the address, and this is the value, the variable itself, 52. These are the addresses, all kind of addresses here. Okay, 53, 54, and so on. And when we create a variable a, now the computer kind of randomly chooses one of these slots, let's say this one, and now the address will be 53 in this example. So a is pointing to an integer slot where the address is 53, and now if we assign a value using the a into this variable, we need to put the asterisk. This is called dereferencing. So differencing a equals then. So now we get access to the integer variable itself, and the then will go there, right? Okay. So this is the way it works. So we create a variable, it has an address, and using that address, if we put asterisk here, we can get access to the integer variable itself, like that. And now the pointers can point to different locations. Like let's say we have another pointer here, integer b. Okay, we can now set p point, let's say p points to 53. Pointer actually has an address value, so we first tell b that where is it pointing to. So b is pointing to the memory log 53, and now if I say asterisk p equals to 100, for example, well, let's say 101, it will put that here, isn't it? So we used p to access the value what a was using before. So so b can point there, and now we can change. Next we can change where b is pointing next. We can say, okay, b is pointing now to, b has an address value 51, and if we do asterisk 51 asterisk p, sorry, and we put 35, so where does it go? Well, you guessed it, it goes there, isn't it? So 35 goes there. This is how a raw pointer. This is the 70s, 80s, you know, 70s, 80s pointer. And as I said before, we need to remember to delete this guy. We allocated this slot 53. We need to destroy this memory when we finished. We need to say delete after, otherwise we are in troubles. Nobody else is gonna delete it. And now what the unique pointer does is that unique pointer, and let's call it u. Okay, now if u takes access, let's say u takes ownership of a, okay, something like this. Now u is also pointing to this memory block now, so u is a unique pointer. It's also able to point, and it's the same thing here. We can say asterisk u equals to, let's say 30, so that value will go there. So unique pointer works basically almost the same as the raw pointer, but it just has a couple of extra rules, and it automatically deletes this memory. But conceptually speaking, it's the same as a raw pointer. Conceptually speaking, this is a pointer. Okay, so this is a kind of messy representation, I guess, but I hope you got a little bit understanding from there. So let's start cracking now. So throughout this video, I'm gonna use objects to allocate memory, so it's nicer. I'm not gonna use integer or any floats because objects are more fun, so to speak. So in the first lesson, I will be using person struct to allocate the memories. So I'm gonna create a struct here. Okay, so this is a struct, and I will explain this now. So there's a person struct representing a person data, like a person has an age and person has a name, and there is the constructor to create this person. So normally we will go something like this: person 1, and then we will call the constructor function here. We will pass the age, let's say 45, and then we will pass the name John. Okay, and there it is. And now at the end of the day, the 45 goes here and John goes there. So this is the normal creation of the objects. And when we are creating the object, we will print this, that created player name and then age. And when we are destroying the object, we will also print the message that this guy was deleted. And this object P1 will be destroyed at the end of the scope, which will be here in this case. So let's just run this for fun. We should get two messages. We should get this one, and then at the end of the scope we should get the destruction function call, so to speak. And I'm gonna put the dot here just to illustrate this. Okay, so here we go, and we can see that the console is empty. I go one line forward, the dot is now here, and we just created the player. There's the message player created John age 45, and now I'll run the program, and we can see that the destruction was called here. Okay, so this is the thing I'm gonna use now in the first lesson. So let's start cracking and learn how to use the unique pointer. In order to run the first lesson, I'm going to create a function called lesson1, and here we go. Okay. So first, let's create a unique point object here. In order to use this, we need to include the memory. So we go here and say memory. Okay, so when we create unique pointer, it is at the null state. It's a null. It's conceptually speaking null. It's the same thing as if we create, it's not the same thing, but it's a similar thing. If we create b and initialize it to null pointer, it's conceptually speaking exactly the same thing. So this is null the same way as this is null. Okay. Okay, and then we can test this thing like this. We can actually test that here. So we can test this unique pointer by just putting if, because this unique pointer returns a true or false. We can ask the Boolean value of this unique pointer. It returns true if it's allocated, and if it's null, it returns false. It's like this. So actually we can do like this. We can actually take the Boolean value of the unique pointer, like let me call it d, and it's false now because it's null at the moment. If it's null, it's false. So if I run it now and put the dot here, we should get that d is null. And as you can see from the tooltip, it is null at the moment. So it will go here, else block. There is no player. We did not allocate the player yet. So we get the no player at this point. So let's continue now. Let's allocate the memory now. So this is going to be like the new with the raw pointers. This is how we are allocating memory. We say make unique, and then we put the type, what do we want to allocate, and this will be the construction parameters go here. So in this case we have construction variables age and name, so we need to put 24 and some kind of name, and now it's allocated. And if I do the same thing now, we should have a value there. Put it twice so I can debug it. Let's run it now. Now it should be true here, because it has a boolean function, this unique pointer. So there is true now. That means that it has been allocated. It is not null anymore. Okay. I can delete that one now. Okay, and now if we test it now, we already tested it, but let's test it again, just in case that it is not clear yet. So so if we test it now, if player, now it goes here and prints this one because now it's not null, and we can then use the pointer. So here it goes. Player John joined. Okay, I'm talking about players now here. Okay, so the player joined because we created the object here. We created the object John, and because I'm calling player, so it's a player joining to a game. And now we created the player, and we can see that there is the construction function. Yeah, we just created. We can see the created player here. that happened on this line. I can actually run it. Let me run it one more time, line by line. I'm debugging it now line by line. So here we go. And this is empty. There's no player. That's the old message. I go one line forward. There we go. And we created just a player. It called the construction function here. And now we're gonna go one more line. It's gonna print that thing there. So I'm gonna run it now full on one more time. So it says the player joined because we just created, and then lastly it will be destroyed when the scope ends automatically. Okie dokie. And I can show you one more time that if we create it using the 80s way, using the dynamic memory allocation, we call it p equals to new, and I will create this object like this. And we call it Peter and 25. So if I run this one, it will allocate the memory and call the construction function, but it will never delete this thing. Let's run it. So here we can see that the Peter was created here on line 35, but Peter was never deleted because we did not call delete. Let's continue. We can now delete this memory dynamically on a separate line like this. We can call reset, and reset is deleting the old memory. Okay, so this one deletes immediately the memory, and we go there. John joined, and now when I go one line further, we can see that the destructor was called when I called reset. So reset is destroying the memory at that point when it's called. Okie dokie. And now if we test this on the next line, I'm doing the same. So it should be null again. So it should print now that no player exists. If I run this, and there it goes. Just 1 second. It's gonna be called. So this is the destructor on line 36. I called reset. So it's gonna call the destructor, and then it's gonna say no player because it's null. So it's gonna go to there. Okay. And the next thing, what happens here is that if we are allocating new memory using make unique, it will destroy the old memory at that point immediately. And we can check this thing. If I comment out this section from here, we can see that very clearly, because at this point there is John, the player is John, and when we go here it should destroy John and allocate a new memory for Brian. And let's see that happening. So I'm gonna put a breakpoint on this line. Okay, goes on that line. Player John joined. And if I go one line further, we can see now that Brian was created, and then the John, the old one, was deleted. So now the player, we can see from the tooltip that the player is now pointing to Brian. So the John is gone now. John is destroyed, and then it will print that. I'll run it one more time. Print that. 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 Print that we can see the print at the end. So it says that player Brian joined here, and then it will destroy the Brian at the end. Let's go the next one. Let's go through the next one. Okay, so let's say now that we want to, at some point in a code, we want to get rid of the unique pointer, and we want to pass the ownership of whatever it's owning at the moment, which is Brian in this case. At the moment, the player is owning the Brian person. Let's say we want to pass the ownership of this one to this old row pointer, and this one now should own Brian. So this is how it works. We call release. So release will release the ownership of what it's currently owning. Currently it's owning this Brian person. And after this release, obviously this player is now null because it lost the ownership. So unique pointers are used for ownership thing. And this is very important here. Always, the rule of thumb is that always when you want to own the memory, we want to use the unique pointer. If you want to only refer to a memory, we can use the row pointer. So that's the rule of thumb. We can talk about that later. So unique pointer always means that it's owning that memory. But let's say we want to release that. So now this owns player is now pointing to this Brian, but this owns player is now responsible to destroy this person. If it doesn't, there's going to be a memory leak. So there needs to be a delete at some point. But before we do that delete, let's just do some printing here. Okay. So what if we do some printing here? Player does not own the memory anymore. Yeah, so we are testing this player now. As I said, it should be null. So we should get this message because I'm testing here that if not player, then we will print this. So it should print this message. And then because this owns player is owning it now, so it should also print this one now. So the owns player is the new owner. Let's run this one. Okay. And let's see what happens here. So Brian not owned by unique pointer anymore, so it prints that line 54, and then it prints also this line 57, owns player name. So now this one is pointing to Brian, and we can use that pointer to get access to its members. And now we need to remember to delete that thing, because now this row pointer is owning that, which is a little bit dangerous. This is not really what we normally want to do. This is very rare that this kind of thing should happen, really. But if this happens, then we need to delete the memory and need to set this pointer after that to null. And then next thing, what am I doing next? So we are creating a row pointer again, and we are allocating memory. This is the old way to allocate memory. So how can we now assign this one to some kind of unique pointer? How can we pass the ownership of this person Joe to a unique pointer? The way we can do it is like this. Okay, so I'm using this old unique pointer which we've been using all the time, all the way from here. And at the moment, when we come here, because we released that here, so at the moment it's pointing nowhere. So it's ready to receive new object. and that's what we are doing here. We are calling make unique. Actually, sorry, we are not doing it yet here. We are doing, sorry, we are not doing it. What I'm doing on this line is that I'm creating a new person called Matt, 44 years old, Matt. So now at the moment, the unique pointer is pointing to this Matt person. Okay. But on the next line, I'm using the reset. If you remember, we used this reset before. Where here, and that deleted the old memory. But we can also pass a pointer, new pointer, to the reset. And what this one does is that it will take ownership of this pointer, and it will destroy the current memory. The current memory is this one, the Matt. So this reset will destroy where it's currently pointing to, which is Matt, and then it will take ownership of the new raw pointer. Okay. And after this line, it's very important that, because the player is now owning this memory, so now the second player can't anymore delete it. This is illegal. Okay, this will probably crash the program, because the player is now owning this memory. This one should not do anything to this memory anymore. No ownership anymore. This is wrong. This is wrong. Totally wrong, like this. This should not be done, because the player is now owning this memory. Only the owner can delete the memory. That's the rule of thumb. Okay. But this is how we can change the ownership of memory. And last thing what I'm doing, I think this is the end of this video. So last thing what I'm gonna do is I'm gonna show what I'm showing here. So I'm creating like a section here. So I'm creating some player. This is the raw pointer, and then I'm allocating. I'm doing basically almost the same thing as here. I'm creating a unique pointer here, and I'm initializing the unique pointer by taking ownership of this jack object. And again, the same thing what was here, that the some player pointer loses the ownership of this one, and the some player should not destroy anymore. So the same thing is here, that the some player should not try to delete that after that, because the third player will automatically destroy it at the end of the scope, which is here. And let's now run this one more time, and let's see the print at the end. Okay, so let's see what we have. We have a lot of destroying and creating. Let's see a little bit this one. Okay, so okay. We can see that the jack okay, so the jack is created here. So it's that line 70, and then the jack is deleted here. The jack is created here and destroyed here, and we can see that on these two lines. And then the Joe was created, so the player took the ownership of the Joe, sorry, here, and so that's deleted here. And Matt is also deleted here. So this one happened. Okay, so this one happened when the player started to point the Matt. We created the Matt on this line using the make unique. So goes there. We created the player, and then we are calling reset on line 65. So then this newly created Matt was immediately destroyed. Yeah. Okay, so this is the first lesson, and I will continue from here. and we will go to more interesting things next. Okay, thank you for watching this video and see you on the next video.